Hello, let's continue our Sudoku adventure with Barney's Folly by Randall. So we have a 6x6 chaos construction. So what does that mean? Well, first of all, we are still a Latin square. So in each row and each column, we are placing the digits 1 to 6 exactly once each. And instead of our normal boxes, we do have essentially irregular regions, but we don't know where they are. It's up to us to discover where they are. So maybe this is a region here, and we can use I recommend enabling the line tool in the options. A pen tool is what it's called. It's the very, very first option at the top under tools. If you enable the pen tool and go to black, then you can just draw black lines like this, and then that can denote your regions. And a region is always 6 connected cells, fully connected, and they can't connect diagonally, only orthogonally. And those regions, there's going to be 6 of them, and each region has the digits 1 to 6, exactly once each. So like we would have 1 through 6 in here, and then we could have another region like maybe a box like that. And then maybe another region would be, I don't know, something like this. 1, 2, 3, 4, 5, 6, 8. And then you'd end up just drawing out your 6 regions. But it's up to us to discover where they are. And there are going to be rules that dictate how we discover that. All right. In addition to that, we do have Renban lines in the grid. That's these purple lines. Digits on a line. Let's just take the short 3-length line. Digits on a line form a set of non-repeating consecutive digits, but in any order. So think about 3 consecutive digits in a row, like 2, 3, 4, or 3, 4, 5. And that's going to be on the line, but we can do any order we want. So maybe it was 3, 4, 5, then we could do like 3, 4, 5. And so you take the set of all the digits, and if you were to sort them, they would create a continuously increasing set of digits that will increasing by 1. Right, 3, 4, 5. Right, continuously consecutive. All right. Anyway, in addition to that, Renban lines do not cross region borders, so we're not allowed to draw a region border here because a Renban line is not allowed to cross it. Right. In addition to that, we do have these black crop key dots. Digits separated by a dot have a 1 to 2 ratio. Another way to put that is 1 is exactly double the other. So if this was a 2, this could be 1 because 2 is double 1. Or this could be 4, because 4 is double 2. The order doesn't matter, just the big ones double the small one. Additionally, black dots always straddle a region border. So you always need a region border here. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Well, of course, I'm going to start by just drawing a region border across every black dot. I'm also going to draw the outline of the whole puzzle. There we go. Okay. So I'm going to use colors for our regions. I'm just going to use all 6 of the colors on the basic palette here. So we're going to call this the green region. And we know this is a different region than green. So we'll call it the purple region. Now we know the green region is 6 cells long. So it's got to grow. And there's only one direction to grow. So we have to take this cell. And now we know that Renbans are all contained within a single region because they can't cross region borders. So that actually finishes green right away. So we can actually just draw the border around green. So we know that this digit is either a 1 or a 6 because this is a 5-cell Renban. So what digits can a 5-cell Renban be missing? Well, it can only be 1 through 5 or 2 through 6. So it always has 2, 3, 4, and 5 in it. It can only be missing an extreme digit, either the 1 or the 6. And that extreme digit goes here in that same region. So that 1 would go with a 2 and the 6 would go with a 3. Now purple does have to expand, it has to grow, so it's going to grow here. Now purple cannot grow to the right because this is 5 cells long. So if it grew to the right, it would take 5 more cells and it would be 7 in size. So we can draw this border here. So purple does have to continue. It does take these cells. So that's 5. And then we know that because of this region border here, this has to be a different color than purple. So we'll make that orange, and then that does mean there's a border there. Now this whole Renban is orange then. And now we know we can't take any of these cells. We only have 1 more cell to take. And so we can't take these 3. So we need to draw this border here. And so that does mean this is a new color because purple can't reach it and orange isn't allowed to be it. So let's just give this the red color. And now we know this cell here, because it's across the black dot, has to be a different color. So let's make that yellow. So we've already have most of our regions defined. Yellow has to get out. So look how much it has to get out. So it has to go down here, get out here, and then it has to take all 3 of these. So, and that finishes yellow right away. Now this cell here has to be in a region, so the only choice is purple, and that finishes purple, and luckily that does give us this 1 cell for orange. Red has to come up and take all 3 of these, which does finish red, and then this is going to be our final blue. All right, so we're done, right? No, we have to do digits now. Okay. So this is also a 1-6 because of the 5-cell Renban. A 3-cell Renban and a 3-cell Renban. So one of these is 1, 2, 3, and one of these is 4, 5, 6. These both are on black dots, but this one's not. I'm trying to decide if like one of these can't be 4, 5, 6 because it would put a 5 on a black dot or something, but I don't see that. What's this going to be? Because this is a 2 or a 3. So it's not 1, 2, 3. It's not 2, 3, 4. And it's not, I guess it could be 3, 4, 5 or 4, 5, 6. So it has 4 and 5 on it. Okay, this can't be a 5 because you can't put a 5 on a black dot. If you halved it, it would be 2.5. If you doubled it, it would be 10. The 3 and the 6 go with a 3 or another 6, and the 4 has to go with 2. Interesting. What are we? Okay, so maybe we need to do some irregular Sudoku here. So, yeah, so here we go. This is it. This digit here, where does it go in this column? What do I mean? Well, if this is a 3, then we can't repeat a 3 in these cells, but the column still needs a 3, so it's going to go there. If this is a 4, the column still needs a 4, but it can't repeat in the region, so it's not in any of these cells, so the 4 would go here, and etc., right? So this digit is the same as this digit. And if you look, this is 1 or 6, this is 3, 4, 6. So 6 is the only option. That makes that a 3, that makes that a 3. That's our 1. And this is a 4, 5 pair. Very nice. So this is 1, 2. This 1, 2 has to end up here in yellow, but it can't be 1. So that's a 2 and that's a 2. That ends up being a 1. This 2 sees every cell in red except for this one, so that has to be the 2. Can't be next to a 1, so it's next to a 4 on this black dot. 2 is next to 1 or 4 here. But it can't be... Oh, okay, so either way, this is a 3. Interesting. So if this is 1, then we're 1, 2, 3. If it's 4, then we have to be 2, 3, 4. So this is a 3 regardless. And this is the other 4, 5 for the row. Okay, 3 digits in order, can't use the 2. So we're from 3, 4, 5, 6. And this can't be 3 or 6. This definitely has 4 and 5 on it. Is this black dot handy? Or what are we doing here? Oh, right. Remember I said that one of these was 1, 2, 3, one was 4, 5, 6. I already forgot. So that's our 1. This is 4, 5, 6. We can clean it up a little bit. Makes this the 3 at the bottom, which means this does not have 3 on it, meaning this is a 1. 3 does deet do in the corner, by the way. Celebrating 3 in the corner, 3 in the spotlight. All right. 6 is in one of these two. I wonder if that's helpful. Oh, this row needs a 6? One of these two. We know this line has a 6 on it, because it's only missing the 1. But this does not. This is not the 6. Oh, wait, hold on. Yeah, this row needs a 6. Green says not these two. These are filled with non-6s, and this sees a 6 here. So this is our 6. Okay. Left with a 4, 5 pair here. Let's just do Sudoku. This is 5, 6. This is the 6. This is the 5. Just for the column. That's 4 and 5. This is 1, 2, 3. It's not 1. That's not 3. So this is 1 or 2, just for the row. It's the same as this digit. Is what I meant. What am I seeing? Is this limited? Okay, so this can't be 1, 2. For a couple of reasons. I guess the easiest is that this can't be 1 or 2 or 3. So this is 4 or 6. It can't be a 5 because it's on a black dot. 4 would have to go with 2. 6 would have to go with 3. Okay. That's a 1, 2, 3 triple. This is a 4, 5, 6 triple. Wonderful. 4, 5, 6. What am I missing here? 1 in this. Okay, 1 in green is in one of these two. Oh, this is 4, 5, 6. This has to be the 2. That's 3. That does it. That's 1. That's 2 and 3 and 1. In here, we are going to need, let's see, this is a 4, and this is a 2. Okay, and that's 5. This is a 5. All right, and that's a 5. And we have to resolve, the 3 resolves it. That's 6, that's 4, that's 6, that's 4. We get the 4 and the 5, and we're done. Nice. Finished the regions pretty quickly, but then the irregular Sudoku was actually, I wouldn't say challenging, but it took me longer than I expected. Cool. Very nice puzzle, Randall. I enjoyed that. Nice difficulties, but it's hard to make chaos constructions like not super easy, but also not super hard. I think this was a nice balance for this series, especially. Cool. Well, let me know how you did. If you enjoyed this, why not leave a like, subscribe, and a kind comment below. you.